Hello everyone, welcome back to the channel Blue Jacket Life with another video. This is a continuation part 5 of marine refrigeration system. In this system, we will be experiencing on the high pressure cutout used in the refrigeration system, refrigerant filter dryer, and a side glass or a siphon glass with the importance of it. But before moving further into this session, a quick recap onto the actual refrigeration system used on board ship along with the flow of refrigerant in that system. And this is the actual refrigeration system used on board ship. And the flow of refrigerant starting from the discharge side of the compressor, it is sent to the condenser where the condenser is provided with the cooling media for the condensation process. And the condensed refrigerant is sent to the dryer for filtration. After the filtration process, it is sent to the siphon glass to observe the moisture content. After the siphon glass, it is sent to the thermostatic expansion valve. Where in the thermostatic expansion valve, a flash evaporation takes place according to the set point temperature of the evaporator. Now, the refrigerant after the thermostatic expansion valve is sent to the evaporator. And after the evaporation process, it is again sent back to the suction side of a compressor. I think now we have recap on the flow of refrigerant in the system. Here, you can observe that in between the compressor and the condenser, a high pressure cutout is located on the gaseous line of the refrigeration system. Now let us look onto this high pressure cutout used in the refrigeration system, working of the high pressure cutout and the reasons for the high pressure cutout trip to get activated. Moving on to the basics. What is a high pressure cutout? High pressure cutout, as the name suggests, it activates and trips the compressor when the discharge side of a compressor exceeds its maximum value. And remember, it is a manual trip switch. No automatic reset button is present on the high pressure cutout. Now, what are the reasons for the high pressure cutout trip to activate? Overcharging of the refrigerant, loss of condenser cooling capacity, or air in the system. Here you can see the typical refrigeration specification chart. And the refrigerant used in the system is R134A and the charged mass of refrigerant is 105 grams. For this instance, let us think that this 105 grams of refrigerant is sufficient enough for the system to work efficiently. That 105 grams is circulating in the system to work efficiently. Now, due to some reasons, there is a need of refrigerant in this system. Now, we have started giving the refrigerant in the system, but instead of giving 105 grams, we are given 130 grams. So, there is an excess of 25 grams of refrigerant present in the system. Now, this excess refrigerant along with the actual refrigerant will start circulating in the system. And the flow of refrigerant again starting from the discharge side of a compressor sent to the condenser, from condenser to the dryer and dryer to the thermostatic expansion valve. Here the problem arises with the thermostatic expansion valve. This thermostatic expansion valve is set accordingly with the evaporator set point temperature. For example, the evaporator set point temperature is -4 degrees centigrade. That means when the evaporator reaches its set point temperature, which is -4 degrees centigrade, the sensing bulb attached at the outlet of the evaporator will send a signal to the thermostatic expansion valve to stop the operation. Now, the refrigerant charged with the excess amount in the system will be receiving at the inlet side of the thermostatic expansion valve. Previously, I have mentioned this expansion valve is set accordingly with the evaporator set point temperature. Now, let us think that the evaporator temperature is raised from -4 to -1 degree centigrade. Now, the sensing valve will send a signal to the thermostatic expansion valve to operate open condition. When this expansion valve will get a signal from the valve, it will start operating in open condition. Now, due to the excess amount of refrigerant entering in the expansion valve, this excess amount of refrigerant will not get properly evaporated in the expansion valve, as this expansion valve is set accordingly with the evaporator temperature and the capacity of the entire system. But here, instead of evaporating 105 grams, the refrigerant received by the expansion valve is 130 grams. the excess amount of 25 grams will not get evaporated. Will be remaining in the liquid state. This excess liquid refrigerant will be start flowing in the evaporator and again sent back to the suction side of the compressor. We all well aware that liquids are incompressible. When the suction side of a compressor receiving the liquid refrigerant, it start compressing the liquid refrigerant. When the liquid refrigerant will be starting compressed by the compressor, there is a rise in the discharge pressure of the compressor. As the discharge pressure raises above its maximum value, then the high pressure trip get activate and trip the motor, eventually tripping the compressor working. Now, moving on to the second reason, loss of condenser cooling capacity. Here, back onto this picture, you can see the condenser is provided with the seawater for condensation process. This seawater is having the contaminants like seashells, mud. This leads to a marine growth in the condenser cooling tube. When there is excess amount of marine growth in the condenser cooling tubes, the condenser cooling capacity will be gradually reduced. Now the problem arises when the condenser cooling capacity is reduced. Here, at the discharge side of a compressor, the refrigerant is discharged with the high pressure. When the high pressure refrigerant discharged to the condenser, due to the loss in the condenser cooling capacity, there is a development of the back pressure in the condenser. Due to this back pressure, excess amount of pressure rise in between this compressor and the condenser line. In this line, you can observe due to the back pressure here, there is an excess amount of pressure present in this region. Due to this excess amount of pressure, the high pressure cutout trip will activate and trip the motor control, eventually tripping the compressor operation. And now moving on to the third reason, air in the system. But before proceeding on to the third reason, air in the system. This air can enter into the system while filling the refrigerant. When there is a need of refrigerant in the system, this air will start traveling along with the refrigerant into the system. When it reaches the suction side of the compressor, this air will also get compressed along with the refrigerant. But here the problem with the air is at higher temperature than the refrigerant and also at higher pressure than the refrigerant. Already the air is at higher pressure in the system. Now the compressor will start applying more pressure onto the air along with the refrigerant. As it applying more pressure onto the air, there is a rise in the discharge side of a compressor pressure. As there is a rise in the discharge pressure, the high pressure cutout strip will activate and trip the motor control, eventually stopping the operation of the compressor. So now a quick recap onto the three reasons. 1. Overcharging of the refrigerant. 2. Loss of condenser cooling capacity. And 3. Air in the system. And now let us look onto the operation of the high pressure cutout in the system. As we are well aware that this high pressure cutout is located in between the compressor, discharge side and the condenser. The high pressure refrigerant will start entering into the high pressure cutout. Here you can see this below, this is an expansion below. This will expand according to the pressure applied by the discharge pressure of the refrigerant. When there is an excess amount of pressure is applied into this bellow will start expanding. When this bellow will start expanding, it will start compressing the mainspring. And when the mainspring is compressed, this switch arm contact will move according to the pivot point. When with switch arm contact is started moving, it will break the electrical contact. As when the electrical contact is broken, the motor running will also get tripped, eventually safeguarding the equipment. And here you can alter this trip setting with the adjustment screw. And after the tripping, this high pressure cutout needed to be manually reset after rectification of the faults. And for the rectification of faults, there will be a separate video and how to do the rectification of the high pressure trip. So please stay tuned to the channel, and if you haven't subscribed to the channel, subscribe to the channel and hit the bell icon for further notifications. Now moving on to the refrigerant filter dryer. Here you can see in this picture the refrigerant filter dryer, which is used for the filtration process of refrigerant. This dryer is fitted in between the condenser and the thermostatic expansion valve. This dryer is provided with the three connections, one inlet and one outlet and one filling connection to fill the refrigerant when it is needed. Here you can see the cut section of the filter dryer. where the refrigerant will start entering from the lower portion and will start exit at the top portion. When the refrigerant entered into the filter dryer, it will start filling up this porous material. When the refrigerant filled this porous material and this filter, which acts as filtration sheet, when the refrigerant will start entering at the bottom, it is initially filtered with the filtration sheet, which is porous. After the initial filtration, it is sent to the second stage of filtration process, where the contaminant is eliminated. And after this filtration, it is again sent to the other filtration process, where the liquid refrigerant will start filling the dryer. When the dryer is filled with the refrigerant, it will start eliminating the filtered refrigerant at the outlet of the dryer. This will eliminate any excess amount of contaminants or any excess amount of moisture present in the refrigerant used in the system. Here you can see a filter dryer in the refrigeration system or air conditioning has two essential functions. I previously mentioned to absorb the contaminants like water that can create acid in the system or to absorb any physical contaminant. And filter dryer composition, it is a cylindrical vessel, refrigerant entering at one side and leaving at the other side. Here you can see the refrigerant is started entering at the bottom and leaving at the top on the other side after the filtration process. Now, if the refrigerant is fitted in the liquid line, here you can see this is a liquid line up to the thermostatic expansion valve. If the refrigerant dryer is fitted in this line, then the inlet of the dryer will be from the bottom and the outlet will be from the top. But if the refrigerant dryer is fitted at the gaseous line, which is somewhere here between the suction and the evaporator. For instance, let us say if the refrigerant dryer is fitted at this point, then the gaseous refrigerant will be from the top and the exit from the bottom. Here you can see if the dryer is in the liquid line, the flow of refrigerant starts from the bottom and leaves from the top. This is to ensure the flow of refrigerant is uniform contact with the drying agent. Whereas filter dryer, if it is in gaseous line, the flow of refrigerant from the top to bottom. This is also to ensure the maximum amount of filtration to happen for refrigerant. Now, what happens if the refrigerant dryer is not working properly or there is a problem with the refrigerant dryer? I have previously mentioned this refrigerant dryer is used to filter contaminants like water, which are liable to form acids in the system. If the refrigerant dryer is not working out properly, then these contaminants along with the refrigerant will travel in the system. Now, this dryer is not working properly. The refrigerant entering at the bottom and leaving at the top without any filtration. This unfiltered refrigerant will enter into the thermostatic expansion valve due to the pressure drop. If the refrigerant is pressured with the moisture content, it leads to formation of ice in the thermostatic expansion valve and completely blockage of operation in the system. This complete blockage of flow of refrigerant in the system will cause a serious damage to the system. Number one, increasing the back pressure in the entire line due to the blockage of the thermostatic expansion valve by the unfiltered refrigerant. And number two, there is a rise in the evaporator temperature, and the problem with the provisions or other related stores or the problem with their cargo, the temperature will not be maintained. And now moving on to the side glass. Side glass is usually fitted between the liquid line immediately of the refrigerant filter dryer. What are the functions of the side glass? It monitors the actual moisture content in the refrigerant system within at acceptable range or not. And also it indicates whether the liquid refrigerant is always present in the expansion component, and it also serves as the color indication. If the side glass in the green color or it is giving a green indication, that means the moisture content in the refrigerant is okay. If it is giving a yellow indication, there is a problem with the moisture content. There may be a presence of excess moisture content in the refrigerant. Here on this picture you can see the indication of the green and the indication of the yellow. If this side glass is indicating this green color, then the refrigerant is working fine and the moisture in the refrigerant is within the limit. If it is showing in a yellow color, the moisture in the refrigerant is excess and the problem with the refrigerant. Here in this picture you can observe that it is showing in yellow color. That means there is a problem with the refrigerant in the system. There is an excess amount of moisture present in the system. I have previously mentioned that this excess amount of moisture will enter after the unfiltered refrigerant due to the problem with the dryer. Due to the excess amount of refrigerant in the system, it will cause a problem with the thermostatic expansion valve. If the moisture content is excess in the system, it will lead to complete blockage of the thermostatic expansion valve passage and lead to rise in the evaporator temperature and also increase in the back pressure in the entire line up to the discharge side of a compressor. Monitoring this siphon glass will know the actual refrigerant condition in the system. Now I think you have got an idea on the high pressure cutout and the importance of high pressure cutout in the refrigeration system and the importance with the filter dryer along with the siphon glass. In the next video, we will be experiencing on the thermostatic expansion valve. So please stay tuned to the channel, and if you haven't subscribed to the channel, subscribe to the channel and hit the bell icon for further notifications. Thank you.